Okay, hi, welcome back to our glaciation topic, which is part of the lithosphere unit. And today we're going to be looking at three more glacial features of erosion, having already covered a corrie and its adjoining features, a pyramidal peak and a ret. So today, what we're going to be looking at a bit more specifically is being able to explain the formation of glacial features of erosion, obviously, continuing at learning intention, and looking, as I've said, at these key features in bold with ticks, a U-shaped valley, a ribbon lock, and a hanging valley. The key there represents the fact, as I've said before, that a U-shaped valley, just like a corrie, is a key feature, meaning that if you can explain that, you need an extra sentence, really, to explain the formation of a ribbon lock or a hanging valley. So we'll just go through the slides just now. And I'll talk you through that and the activities you're meant to be doing, which you have on your Google Classroom. A little reminder about how glacial features of erosion are awarded marks. The key bits from that, you've got this in the last lesson too, are that you get up to 6 marks for fully developed explanations of processes. And that is that key idea that I gave you in the rivers topic and the coast topic, that you'd need to talk about how that process works, where that process works, and how it changes the feature actual shape. You also pick up 2 marks for talking about how glacier forms in these questions. So actually you can get 8 marks just from talking about these processes and how a glacier is made. And then you need another couple of bits to kind of really guarantee yourself these full 8 marks that generally are awarded for features of glacial erosion. Try and make sure answers are given around diagrams, which is why I'm getting you to do this on this activity during our pandemic home learning. Your starter, try and write a definition or description of each of the following terms, recapping a little bit from what you might already know, and especially having looked at the some key terms of glaciation in our Quizlets we've looked at. Do you know what these are? Okay, next, I'll kind of imagine you've paused it and go over these. So your corrie is this bowl-shaped depression where we saw from last time, and a ret is where we've got 2 corries back to back. A horn is another word for pyramidal peak, and is where we get 3 corries back to back. And a tarn is another name for a corrie loch or a corrie lochen in Scotland also. Corries are also known as kims in Wales, or you might have heard them called cirques in the Alps. Task 1, I normally give this diagram out in class and you match up the features with the diagram. Obviously you're not going to be able to do that, or what I suggest you do, you could, if you really want to, make a little sketch. You're never going to be asked in the exam to tell me what all of the features are of a glacial landscape, but maybe just have a go at this. You could do it on a whiteboard or on a piece of paper, list the numbers and match the features. If you want to submit that, that's fine. It shows your learning. And the answers are on the next slide when you're ready to unpause and just check your own work. So there we go. The corrie is this bowl-shaped depression in 3. The U-shaped valley is this whole thing in number 10. You can see at the end it's got a sort of U profile. If you imagine these cliffs on the opposite side, it would create this U shape. Alluvial fan is number 5. It's where we've got lots of scree falling, in this case falling off a hanging valley and dropping to the bottom of this U-shaped valley here. Pyramidal peak is number 1, 3 corries back to back. You can't see on the other side of the mountain, but imagine there's a corrie there, one here, and at least another one there. We've got an arete is number 2, this knife-edged shape between 2 corries. Number 6 was the ribbon lake, or ribbon loch, as we call them in Scotland. A misfit stream is number 8. Why is it a misfit stream? Well, let me put it to you like this. Did this stream create the valley this size? And that is really your answer of why it's a misfit. There's no way on its own this stream created a valley this wide, and what's actually happened is obviously there must have been a glacier to make it this much wider. Number 4 is this tarn or a corrie loch. You might have got them muddled up, a corrie and a corrie loch. The numbers are quite close and they're kind of similar, but as long as you get the idea. And a hanging valley, you can see there's a huge example here, but number 9 is a hanging valley also. Truncated spur. This bit of land before glaciation would have jutted much further out into the valley, and it would have been like a V shape like this. So each of these little lines running down, if you can see my cursor in the valley around number 4, are little spurs, and you can see how the river that runs down the valley from number 4 kind of is sinuous. It's like snakes along the valley bottom, and those little bits that jut out that make the bends are spurs, and they interlock. And what's happened in the case of the U-shaped valley, they're much bigger. So these arêtes effectively would have run right down as called spurs, and they've been truncated. That just means cut off, and then it becomes what we call a truncated spur. And it's quite obvious on a map or on a diagram. There's this big triangle where you can see it's just been cut off completely. And that gives you an idea of this kind of glacial landscape and some of the things we're looking at in terms of the features of erosion. I'd meant to take this back out. These are some diagrams for myself. I'll remove those from the slides. So formation of a U-shaped valley. Have a little look at the Time for Geography clip about the formation of U-shaped valleys. It should be there on that link to start you off with your learning. And what you're going to do for this learning, there are 4 diagrams that I've created. And I want you to copy the notes and the diagrams around them. I'll just discuss through them. As always, I would suggest you have an A4 landscape page or a A4 jotter and take a double page for this. So your first diagram, you can see it's titled Before Glaciation. So we've got no glacier there whatsoever at the moment. And what we happen is we have a period of cooling and glaciers start to form. How does a glacier form? Remember, that's your first 2 marks you get for every feature of erosion question or landscape of erosion feature. So for a corrie, for a U-shaped valley or any other features that go with it, a glacier forms in a north-facing hollow, 1 mark. Snow is compressed to form firn and névé, and a glacier moves downhill due to its weight and gravity. That gets you those 2 marks, these first 2 bits, and this can even get you an extra mark. So it's possible 3 marks. Your first diagram is showing that it's just a river just now, and the valley shape is V-shape. So it's part of your progression. You need that diagram. It's also worth noting, you can see I've said glacial trough. A U-shaped valley is sometimes called a glacial trough. So if you see that term, that's what it means. Your diagram number 2 is during glaciation. You can see my glacier has now appeared. It's filled this V-shaped valley, and within it I've drawn little rocks to show that the glacier carries rocks within it. And little lines at the top represent crevasses or cracks in the glacier. What we're getting is abrasion. So I've got a process I'm talking about. I've identified where it's taking place at the sides of the valley or at the bottom of the valley with my arrow, so I don't need to talk about it particularly. When the angular rock embedded in the ice grinds the bedrock, making the valley deeper. So I've said what it does to the shape of the feature, it deepens it. I've said where it happens and how it works. So I'm opening up my options for getting 2 marks for a detailed explanation of a process. And the beauty of labeling, it means you don't need to specifically say it's on the valley sides or the valley bottom. It's labeled, it shows you its location. Diagram number 3, what we've got happening, you can see the valley shape starting to change from V to a U shape. Plucking, that's happening on the sides of the valley. It occurs when ice freezes onto the bedrock, pulling loose rocks away from the valley sides, making it steeper. So the sides have become steeper from being at an angle to being much steeper. So I've talked about how it's changing shape, where it's taking place. Still got my glacier, still got my bits of rock within the glacier. Frost shattering, and perhaps I could have had this arrow higher up, but it happens on the sides of the glacier too, underneath the ice. It continues to steepen the sides of the valley when water and cracks in the rock turns to ice, and when the temperature drops below freezing, expansion and contraction weakens the rock until parts are broken off, and they can be plucked away from the valley sides. Or this frost shattering can happen above the glacier, on the land above it, and contribute material to the glacier, which can help with the process of abrasion. So lots of marks for processes, and easily 6 if you're talking about plucking and abrasion and frost shattering, and all of your answers for erosional features. The last diagram here, I've got a couple other diagrams. I don't need you to copy them. They're just useful for your understanding. But the main central diagram is after glaciation. You can see my glacier has gone. My valley is much deeper. Okay, much deeper, much flatter at the bottom and much wider, and it is quintessentially a U-shaped valley. So marks you'll get for this is over time the glacier has caused the valley to become straighter and deeper. You can see that on the bottom left-hand diagram. Yes, there's a big curve in the valley, but generally speaking, it's a much straighter valley than it was when we had these these spurs that were running right into the valley. And I'll talk about that in a second. So you can see in the top left-hand diagram, we've got these interlocking spurs, and often when I'm in the classroom, I get you to lock your fingers together and then look at your palms. And if you look down where your fingers join, you can see there's kind of a snake shape. And if you hold your hand in a sort of V shape, looking down on that, you can see that would be your V-shaped valley with a river snaking along it, and your fingers would be the spurs jutting out into the river area. What happens when the glacier comes is it cuts those spurs off, and that's what makes them become truncated. So by saying that in this question, it's part of the U-shaped valley formation. It's changing the shape of the valley because it's removing the interlocking spurs because of the glacier, resulting in these steep crags and truncated spurs. So there's your steep crag, the truncated spur up above this triangular shape in the bottom left-hand photograph. That gives you a real idea about how these features form, and easily you're picking up your 8 marks if you're discussing these things. Just for your own notes, a truncated spur, you are unlikely to get a question on this particular feature on its own, but you'd be talking about U-shaped valley if you ever did, and I very much doubt you would. But for your own knowledge, there's my map. I've got my contours quite close together, showing it's quite steep, my river running in between this area, and what we'd call a V-shaped valley. Now, a spur is the land jutting out in towards the river here, and the one on the other side, this land jutting out towards the river. Okay, so what's going to happen eventually is these interlocking spurs, because they are literally connected like your knuckles if you put your hands together, and the glacier comes through, smashes, and what we call bulldozes through these features, and effectively that leaves us with truncated spurs. They've been cut. Okay, so hopefully that helps with your understanding a bit more. And at the front, we've got a little terminal moraine where the glacier, the bulldozer, pushes sediment, I guess, to the end, to the most furthest point it can ever reach. When it melts, it's left this kind of arc shape. And we'll look at that later in the features of deposition. Right, formation of U-shaped valley or glacial trough, your task. I want you to have a look at these marking exercises. So normally I'd hand out, we give you a little handout in class, and you have a go at marking these answers. Actually, I did 8. I don't know why I've got 10 there. It's from an older piece of work. Say what you think is good or bad about each of the answers. Would you add anything different, and rewrite out the answers and diagrams to suit your own revision needs? I don't need you to rewrite out any of these questions. I'm going to change this PowerPoint. But I do want you to have a go at marking them, see how many marks you would have given for it, and think about my discussion I'll have with you, which normally would be in class, on this after you unpause the video and have a go at this task. I'll discuss some points from them. There's your marking scheme to go and have a look at the answers with. Let's remember 2 marks for formation of a glacier, 6 marks for processes, and lots of other points you could have in there. So candidate 1, give a tick for a mark, and a wee shape like this, called a caret, that for an expand point where they haven't said enough and they need to say a bit more. That's normally how I mark your work, as you'll have seen before. So if we're going to have a look at this question, you can pause it now and I'll kind of go over it afterwards. What I would say to you is a U-shaped valley forms when a glacier moves downhill. They haven't said how it moves downhill. They haven't talked about internal deformation or basal sliding. There are ways they could have expanded that a bit about how the glacier moves down under its own weight due to gravity. Through an existing V-shaped valley, there are sort of key principles they're talking about, but they're not getting enough detail in here at all for a higher answer. They've said eroding. They haven't talked about the processes of erosion or even weathering, which could pick them out mark. Remember, just a list of 2 gets them a mark, and that's where we get a first mark. They've mentioned plucking and abrasion. 2 just words of erosion gets you a mark, even without an explanation. They don't have 4, so they can't get an extra mark for frost shattering. But if there were explanations for each of those 3, where they happen, how they work, and how they change the feature shape, then they could get up to 6 marks. The ice deepens and widens the valley. Doesn't really cut it. It needs that explanation like I've talked about. And a misfit stream is often left behind. They haven't even described what a misfit stream is. So 1 mark has been given for that answer. It's not a particularly good example. Candidate B, have a look at this one and pause the video. Have a think about what's missing at the end as well, and I'll kind of go over that. And in fact, what's missing is missing from both answers if you look at the marking scheme too. So you can unpause whenever you're ready. So glacier flows down an existing V-shaped valley. Interlocking spurs are removed and truncated spurs are left behind as the glacier bulldozes its way downhill. Yes, I'll give a mark for that. More about the truncated spurs and that explanation. I'd always start your answer off with, you start with a V-shaped valley. But that's clear from your diagrams if you do the diagrams. So make sure you've got those, and that saves you writing that. The immense weight of the glacier as it moves downhill aids processes such as plucking and abrasion. They haven't talked about how it moves downhill, but they have mentioned 2 processes, so they get a mark, even though they've not explained them yet. Plucking occurs when ice freezes onto the slopes, and the glacier moves it off as it moves, steepening the sides. They said how it works, where it works, and they've explained it, so that's getting them a mark. The rocks will assist abrasion, where rocks trapped at the bottom of the glacier scour away the landscape, deepening the valley. I've given a mark for the explanation of abrasion, how it works, and they've said where it happens and how it changes the valley shape by deepening it. Frost, freeze-thaw, action, further assist process. They haven't explained it, but they do next sort of bit. As ice melt, they haven't explained it, so no mark, sorry. As the ice melts, U-shaped valleys left behind with steep sides of valley floor. They just need to expand a little bit more and maybe talk about the fact that it's left with it straightens and widens the valley floor. So it straightens the valley overall and it widens it, and that would have been a better way of putting that to get them a mark. A misfit stream or ribbon lock can be left behind. Yes, but are generally not always getting a mark. So I've given a mark there simply for that because the diagram shows with their progression that it gets steeper, wider and deeper, and I'll show you a diagram on the next slide in a second. What is missing? Hopefully all of you have realised that none of them have talked, neither candidate A or B has talked about how glacier forms. They've missed those 2 marks about ice or snow collecting in a north-facing corrie and compressing and turning to neve and glacial ice, creating the glacier which moves downhill due to gravity under its own weight. That's these 2 marks they could have added on. In actual fact, that would have given that candidate 9 marks out of a possible 8. No, 7 marks, sorry, out of a possible 8. So they would have had a much better answer just by adding that little point on. Right, there's your diagrams. So that candidate has identified where the processes happen, how they work. In actual fact, they probably would have got a mark for freeze-thaw because they've got a little explanation and where it happens as well. So probably full marks actually for that candidate. Right, just a little idea. If you're in the classroom, I would normally show you this. I think you need a login for this, but you can have a little, you can try and click on it. I don't think it will work for you, but I normally show you landscape 3D with Ordnance Survey maps. And this is ArcView GIS or ArcGIS 3D for schools. It's quite useful. But really, you're looking at something where the contours really spaced apart to show that it's or far apart, which shows that the land is quite flat. And where the contours are close together, it's very steep, in fact, almost vertical on the side. So you might actually see the crag feature formation that you can see in the key on the survey map. And you can see here on these 2 pictures, the crags I'm talking about. If I look at the this is Glencoe, the valley, and actually for the ArcView or ArcGIS scene viewer shows you Glencoe that I've saved. And these are crags at the side of that U-shaped valley, and the flat valley floor is really clear because it's very white, so the contours are very spaced apart. White wouldn't cut it, but spaced apart would. But you're unlikely to get any questions which involve maps at higher, specifically about the formation of features or recognising features. That's more of a National Fire level question. And there you can see a hanging valley. So in actual fact, on the top left-hand corner of that, you see the valley hanging into the U-shaped valley, an alluvial fan at the bottom, an actual fact, and a waterfall. So in actual fact, you can see straight away, if you explain the formation of a U-shaped valley, you're actually on your way to explain this hanging valley, and I'll show you how that works just now. So some pictures, U-shaped valley, very flat valley floor, steep sides, cliffs in places. There's actually a ribbon loch down the end. Here's actually a valley glacier still in place, creating this U-shaped valley, grinding down these interlocking spurs that would have been underneath as it goes, and another one underneath. So really some examples from real life, if you like. Can you spot any features of glacial erosion on that picture? So freeze your screen, have a think, how many can you identify, and I'll point them out to you in a moment. Okay, you can unpause. So you can see here, we've got a waterfall, and we've got a sort of V, a U sort of shape, not probably a V. And this is a valley coming down here and pouring into another valley. So this is a hanging valley. This is our U-shaped valley. You can see flat valley floor filled with trees, very steep sides. So this is Yosemite National Park in the US. Very glaciated landscape. And some other sort of features. There's probably a misfit stream within here, though you won't be able to see it with the forest. We've got our steep valley sides, we've got kind of probably scree slopes and things in here as well. So quite a few features. Trying Truncated spur, so that would have been a spur that went down to the valley, but it's been cut by the cliff. U-shaped valley, hanging valley. Okay, your hanging valley. I guess there's some extra points you can make to expand on a U-shaped valley. So extra things you can talk about are the weight of the glaciers causes them to flow downhill following existing V-shaped valleys. So it forms in the same way as a U-shaped valley, but the difference is because these are smaller glaciers, they don't cut down as much as the main valley glacier. So former interlocking spurs may be cut off by the glacier as it flows downhill, leaving truncated spurs and steep valley sides. You've made that point in the U-shaped valley explanation already, or you should have done. So the width and shape of the resulting U-shaped valley will depend on the rock type and the intensity of glacial erosion. In other words, if you've got softer rock, the valley is going to erode much quicker than if it was hard rock, and that means it's going to be much deeper erosion in the main valley and perhaps the side valley. So this is the point here. Tributary valleys have smaller, less powerful glaciers. That's the main point I'd be making for a hanging valley, which result in less deep U-shaped valleys. And because they're less deep U-shaped valleys, they hang into the main valley. And rivers that flow down them generally come down to them as a waterfall. So that last point is really key to explaining your hanging valley, and you kind of build that onto your answer. You do not need you to copy down this diagram here. I wouldn't ever do a 3D diagram for an answer for a figure. There are notes within that textbook. We've got a set of those in school. I'm happy to use them if you come in and you want to use them for revision. And sometimes I get people to take a note from that. You should have enough already without taking an additional note. And just an extra point, this is an alluvial fan coming out of a valley, and it shows you that sediment being transported out of the valley, perhaps by a river after glaciation, and all that sediment's fanned out. That's what we're talking about, an alluvial fan. There it is on a map. You can see the main U-shaped valley, which is represented by the white space on the map with the contours far apart. Truncated spur is this kind of flat edge here, represented by this. Sometimes crags are beyond that. And then we've got the valley a U-shape or sometimes V-shape. And you know it's a V-shape because the contours point the direction from where the rivers come from as you go upslope. And there's another hanging valley example in the photograph. Right, your last feature linked to U-shaped valleys is a ribbon loch. You need another new title. And these are your last sort of points. So for ribbon loch, you must start with the formation of U-shaped valley explanation and add the following. So I guess what's really quite good about this is there's two ways a ribbon loch forms. If you remember that, you've remembered 2 marks. So the first way they believe ribbon lochs are formed is where softer bedrock is eroded more deeply than the surrounding area, and that is known as differential erosion. We've covered differential erosion already in the course when we've looked at coasts and indeed when we've looked at formation of a waterfall in hydrosphere. So you know it's where soft rock erodes faster or quicker than the harder rock. That's known as differential erosion. So ribbon lochs form where the bedrock's eroded more deeply in the surrounded area, or where a terminal moraine or recessional moraine creates a dam. So an example is Lake Windermere. Can I give you a good example of this? So spot the feature and give evidence. V-shaped valley, U-shaped valley, and a waterfall. What I might just do quickly, I might build this into a slide. I don't think I put it in. Last task I want you to do this lesson, and you can submit me your time it takes you to do it. Go on to this link, formation of a U-shaped valley, high as lithosphere, Quizlet, have a go at the match task and submit me your time, or write down your time on your work today, how long it took you to do the Quizlet, and see if you can beat or get the best time you can get, and see who can get the top time in the class. I'll just show you a picture of a ribbon loch or diagram to give you a little bit of a better explanation. I'll put that into the Google Slides. I haven't done that just yet. So we'll show you that just now. Ribbon loch diagram. So I need to put this one into the slide. I'll just show you it. bigger version. So you can see here, if the rock is softer and this was a glacier running over the top, imagine it was there, all that would happen is the soft rock would erode more quickly, making a deeper gouge, and the ribbon lock could form. The other option is if you didn't have this soft rock that you've got on the screen there, the glacier would bulldoze along and leave a big pile of rocks at the front, and those rocks could create a dam across the river and then store water behind, and that would create a lock too. So that's your two different ways that you've got a glacier creating a ribbon lock, and that kind of ends your presentation there. So complete those tasks and send me your pictures of your diagram and your Quizlet time, and we'll have a discussion later this week.